nomenclature. Nomenclature is the rules governing how chemists name molecules or compounds. Now, there are 5 broad categories that a compound could fall into. And each of the categories has certain rules that are followed for the naming of that compound. The first type of compound or category is when a metal is bonded to a non-metal. For example, when lithium is bonded to sulfur. Lithium's a metal, sulfur's a non-metal. The second category that you could have in terms of naming things is naming compounds that have a transition metal in it. Transition metal is things like copper, iron, zinc. Those are all transition metals. And what's unique about the transition metals is they can have 2 different possible ion states. And to name those, therefore, has a little bit of a different set of rules. There's a third category. And the third category involves what are called polyatomic ions. Polyatomic means that there are 2 or more atoms bonded to each other. That particular bond or those bonds are very strong bonds called covalent bonds. And because of that, those are very, very stable items. And so a polyatomic ion is in fact a molecule with 2 or more atoms connected. It's very solid, but it carries a charge. And when there is that situation, you got a new set of rules in order to name it. The fourth type is when there is a nonmetal bonded to a nonmetal. An example of that is when carbon, which is a nonmetal, is bonded to an oxygen, which is a nonmetal. When that happens, there are other rules that are involved. Finally, group 5 is the naming of acids. And so what we want to do right now is take a look at examples of how to name compounds from these 5 different categories. The first one we'll take a look at is a metal with a nonmetal. An example of that is number 17, where lithium is in fact bonded to sulfur or sulfide. So lithium is Li, sulfur is S. Now lithium, if you look on the periodic chart, it's going to form a +1 ion. It's going to lose 1 electron. Sulfur is going to be a -2. It's going to pick up 2 extra electrons in an effort to achieve an outside valence shell, which is full. Now the way we illustrate that is the following. Lithium is going to lose an electron. When it does so, it becomes positive. Sulfur is going to gain that electron. It becomes negative. However, sulfur needs to gain 2 electrons to complete its outer shell. Lithium has only 1 electron to give, because once it gives that 1 electron, that outer shell is emptied and the next one is full. So we need another lithium to give up its electron to the sulfur. It also becomes plus, and now sulfur becomes a -2. So notice there are 2 lithium atoms, each giving up an electron. There's 1 sulfur taking in those 2 electrons, giving it -2. So we need 2 lithiums and only one sulfur, and the result is this whole compound is now neutral. It's neutral because the two lithiums are a +1, therefore there's 2 plus charges, and the sulfur is a -2, so the whole thing is now neutral. Now, let's take a look at another example of this. Let's see here. There we go. Come on. Work, please. There you go. All right. Another example of the first category, category number 1, is question number 25. 25 says that aluminum oxide. Aluminum, if you look on the periodic table, is a +3. That's because it's going to give up 3 electrons in order to achieve a completed valence shell, which is the next one inside. Oxide is oxygen. Oxygen is going to assume a -2, so it's going to absorb 2 electrons. You'll notice aluminum gives up 3 electrons. Oxygen takes in 2 electrons. There's not a spot available for that 1 more electron from aluminum, so that's not going to work. But if I have 2 aluminum atoms, then this one would give up 1, 2, 3. The second aluminum will give up 1, 2, 3. I now have 6 electrons being released by 2 aluminum atoms. This oxygen would take 2 of those in. There's still 4 more to go. So I would need a second oxygen to absorb 2 more, but there's still 2 left. So I need 3 oxygens to absorb the 6 electrons coming from those 2 aluminum atoms. And so this, therefore, would be aluminum oxide. Now, the second category that we had was the transition metals. Let's take a look at question number 23. Got to figure out how to work this. Come on. Move, please. Come on, move. There we go. Cool. All right. An example of the transition metal problem is question number 23. Now you will notice that 23 says 10 Roman numeral 4